Let's tackle chapter problem 9. The Daijun Company's total variable cost function is given as TVC, total variable cost, equal 50Q minus 10Q squared plus Q cube, where Q is the number of units of output produced. Question A. What is the output level where marginal cost is minimum? Question B. What is the output level where average variable cost is minimum? Question C. What is the value of average variable cost and marginal cost at the output specified in the answer to part B? To answer this question, you need to derive marginal cost and the variable cost. Let's move on. Let's tackle question A. Recall that marginal cost is total cost, change in total cost divided by change in quantity of output. But then total cost consists of fixed cost and variable cost divided by delta Q. So we are dropping T total from fixed cost and variable cost, but they are same. But then remember that fixed cost is always fixed at constant level. So there is no change from fixed cost. Delta FC equals 0. So this is basically same as changing in total variable cost divided by change in quantity. So by taking operation, delta operation in total variable cost that is given in your problem, you can find marginal cost. So remember that variable cost in the question is written as 50Q minus 10Q squared plus Q cube. So when you take delta operation sign and divide by delta Q, after that delta operation you have 50 minus 10 multiplied to Q plus 3Q, 3 minus 1 is 2, right? So that is marginal cost. So we find marginal cost for question A, but then we still have one more step to go. What's the output level where marginal cost is minimum? This is quadratic function. So there are two ways. One way is trying to factor out the two terms with Q square. Inside square there's a linear of Q, and here will be 10 divided by 3 plus 50 minus 3 multiplied 10 divided by 3 square. So these are constant. Here is quadratic term factored in the square term. So when this term becomes 0, the entire marginal cost will be minimal, as the function look like this way. In the bottom, the minimal occur when this quadratic term becomes 0. That happened when Q equal 10 over 3, right? So we can imagine that the marginal cost curve is quadratic form, and the minimum happen when Q equal 10 over 3 from 0, right? So that's the answer for question A. Question B. What about the output level where average variable cost is a minimum? So this one, question B, is easier than question A, as you're given with total cost, and average variable cost is the total variable cost divided by quantity Q. So you have 50 minus 10Q plus Q squared, right? So you can also make the factor operation like this. Then you can find out Q equal 5 minimizes average variable cost. Of course, for question A and B, there are other ways to answer this question. Again, when you are familiar with basic calculus, average variable cost, again, as you see here, look like this convex U-shape quadratic function where minimal happen when Q equal 5, right? So to find the minimum, if you look at the graph, at that minimum, the slope of the curve is 0, which means when you change Q by delta Q, the change in average average variable cost equals 0. In other words, the derivative of average variable cost with respect to Q equals 0. So as long as you apply this principle, then again, which applying delta sign here, you have minus 10. As you cancel out this constant term, but has minus 10, and you get 2Q from Q square from delta operation, or the derivative, and you can find out Q equals 5. You can do the same thing for marginal cost in question A. As we find marginal cost is 50 minus 20Q plus 3Q squared. And we know that marginal cost is also U-shape with one minimum happens at 10/3, right? So that can be found by applying this delta operation or derivative of marginal cost with respect to Q. As we find minus 20 plus 6Q equals 0, you can find Q equal 20/6, which is 10/3. So that's question B. Question C. What is the value of average variable cost and marginal cost at the output specified in the answer to part B? In part B, we found Q equals 5, and we need to calculate marginal cost when Q equals 5, average variable cost when Q equals 5, right? We call marginal cost, we found the form as 50 minus 20Q plus 3Q squared. So when you plug Q equals 5 to this equation, we have 50 minus 20 multiply 5 plus 3 multiply 5 squared, which is 50 minus 100 plus 75. So we have 25, right? What about average variable cost, which we found as 50 minus 10Q plus Q squared in the question B, and plug in Q equals 5. We have 10 multiply 5, 5 squared. Again, this is 50 minus 50 plus 25, so it gives you 25. So we just confirmed that when quantity Q equals 5, both values of marginal cost and average variable cost are the same at 25. And this graph demonstrates that marginal cost cut through the bottom or the minimum of average variable cost. And of course, this graph is depicted in the slide or the textbook with figure 6.2. And you can also think that when additional cost is added is greater than current average, then new average cost will be increasing as you see here. But then on your right, but then when additional cost added or going to be added is lower than the average, the new average will be decreasing. That's the intuition why marginal cost cut through the minimal point of average variable cost. Thanks for watching.